Good morning, everyone. My name is Varun. Today, I'm going to be presenting on my topic, which is exploring New York City's yellow taxi trip data in 2022. Now, we all know that yellow taxis are the lifeblood of New York City, weaving through its bustling streets. Each taxi trip generates valuable data about how, when, and why people move around the city. And by analyzing this data, we can uncover various patterns, trends, and behaviors that shape New York City's transportation. Now, the goals of my project is to identify common groups of taxi users and their distinct travel patterns, discover frequent patterns and associations within trip characteristics, develop a model to predict the likelihood of passengers leaving a tip, and design a model to predict payment type, whether it is cash or others or credit card payment. Now, who will benefit from this research? The main benefactors for this research are taxi drivers, so they can analyze how much tip in advance they are going to receive based on a particular trip characteristic, and they can know where to position themselves in demand areas to increase their overall demand in that particular day. Urban planners can also benefit as they can lay out proper transportation plans based on taxi movements. NYC residents can also benefit from this because they can know how much tip on average people are supposed to give by predicting the tip they were supposed to give for an each trip. They can also know various things like how much trip duration it's going to take for them. The dataset which I used for this has been taken from two sources. One is nyc.gov, where there is NYC's 2022 taxi dataset, which is maintained and sourced by NYC Taxi and Limousine Commission. One more one is a weather data in year of 2022 in New York City. I have taken this from a National Center for Environmental Information in Climate. They maintain an API for this dataset. Raw and clean data. As you can see there from the image on the left, this is the raw weather data which I have is in JSON format. I have cleaned it to get it into this record format. I have a raw and clean data for my taxi as well. The one on the right is taxi data's raw one, which had various null values and other inconsistencies, which I rectified and cleaned it to make it into this clean data set on the right. On the bottom left, I have transaction data, which I'm going to be using for association rule mining. It's also a clean one. Now, initially, I performed exploitative data analysis on my data set, where I uncovered various patterns. Like from the histogram of trip distances, I identified that majority of the trips are between 0 to 10 miles. And from this time series graph, which is average total trip fare over time, which is spanning from January 2022 to December 2022, we can see that as the months go on, the overall trip fare has been increasing over the months. There's another graph here, which is average trip duration over time. We can see that trip duration over time has been consistent, which was between uh, 10, 10 minutes to 17.5 minutes, except in mid of September, it had a minimum and maximum average trip duration. Now, based on rate code, I have another graph here which shows average total trip fare, which is standard rate and based on your airport trip fare as well. From this chart, we can see that the trip fares for airport has been greater, that is JFK, New York, and standard trip rates are lower. Now, the findings and results from my research are as follows. Common group of taxi users and their distinct travel patterns. For this, I have used clustering. Basically, I have used two methods of clustering, which is k-means and hierarchical clustering. I have used, from my analysis, I have seen that k-means had the best results, which showed a distinction of 5 groups are better for this grouping into different taxi users. We can see a clustering image over here on the right. Now, the patterns which I uncovered is that there are basically two groups which favor short, affordable trips in good weather, likely representing local running errands. Dedicated group relies on taxi during rainy weather, showcasing the impact of weather on usage. One group takes longer trips, suggesting airport travels. And there's another final group which indicates taxis are used for group travel or special events, evidenced by higher passenger counts. Moving on to identify frequent patterns and associations within taxi trip characteristics, I have used association rule mining. From my results, I have got a total of 75 rules, and there is a relative frequency plot here. From this, we can see that pickup of Manhattan and drop off Manhattan were the most frequently occurring items, which shows that majority of the trips were in Manhattan, and credit card was the most used type of payment method. There is a graph here on the left which shows various graphs of the rules generated by association rule mining. So my key findings are trips ending in Manhattan strongly favor credit card payments. Most NYC trips are short distances. Discovered patterns are most pronounced during weekends. The link between Manhattan trips and credit card payments suggests a specific user preference. Now, to one more goal of mine was to predict payment method for the trip. For this, I have used naive Bayes. Naive Bayes is a classifier which can classify whether, in my case, whether it is a credit card payment or cash or others. There's a confusion matrix on left you can see over here. Now I have got an accuracy of 71.2%. For both my classes, which is cash or others and credit card, I have got good precision, recall, and F1 scores. My accuracy is lower. It is not too high, like it is above 80 or 90, because majority of the features in my dataset are related to each other. They are not independent. Naive Bayes basically assumes independency between various features. So my accuracy is lower here. Now, predicting the one more goal of mine was to predict the likelihood of passengers leaving a tip. I have used this by decision trees. You can see a confusion matrix on the left over here, and I have got an overall accuracy of 93.8%, which is around 94%, you can say, for my prediction, which is a very good score. And my precision, recall, and F1 score for both the classes is also very high, which is 94%. I have done decision trees with various depths, uh, like with maximum depth with 7, depth with 10, and depth with 5. I have identified that all of them had similar results. So I have chosen depth equal to 5 as the most optimal model. From this tree, you can see over here on the right that there are various things like trip fare, trip duration, trip amount are the most important factors affecting this payment type classification. Now I have performed a similar classification for this using support vector machines. I have used various support vector machines like linear SVC, polynomial, and so on. The best one which I found was linear SVC with C equal to 1, which had an accuracy score of 93.03%. The precision and recall and F1 score for both the classes, that is cash or others and credit card, was pretty good. The confusion matrix of it is on the right over here, left side. So concluding, I can say that people use taxis in different ways. It is short local trips, rainy days, longer journeys, and group outings. Most taxi trips are short distances, making them a popular choice for getting around in the city quickly. Where you end your trip in New York City influences how you are likely to pay. That is mostly if your trip is in Manhattan, mostly people use credit cards for it. It is also found that the weekends are the busiest for New York City taxis. And prediction can be made if someone is likely to tip a driver or not. And we can also, machine learning was also used to make predictions to find the preferred payment method of the user, like whether it is cash or others, or whether it is made through credit cards. That's it. That's my overall research, which I have done for the NYC 2022 dataset. Thank you for watching the presentation.